Hi, ACST1052 students. This is Doug Fletcher with another video of a worked solution in the tutorials on week 7, and this is for question 11, a study on correlated assets. So we have two companies here, Company A and Company B, and the investment returns for these company shares are seen as being related to three underlying variables, C, X, and Y. And the return for company A is equal to C plus X. The return for company B is equal to C plus Y. And C, X, and Y are considered to be independent. We're given some information about the means and standard deviations of C, X, and Y, and then we're asked to answer some questions. So the first question in part A is that we are asked to calculate the expected value and standard deviations of IA and IB, the returns on assets A and B. So here's my working page, and I've summarized the main data here. So just to look at the at part A. So if we're wanting the expected value of the return on asset A, then we unpack this as the expected value of the return on C plus X, which decomposes to the sum of the respective expectations. So we simply end up with 0.05 plus 0.03, resulting in 0.08. And I'll add this to the little summary table that I have up the top. When we're considering standard deviation, the basic rule to remember is that standard deviations don't add, but variances do. So the variance for the return on asset A will be the sum of the two variances. So we'll take the variance of C plus, the variance of X. So we're going to have 0.08 squared plus 0.07 squared, and that gives us 0.0113. Now that's the variance. For the standard deviation, of course, it's simply the square root of that value. And at this point, we're generally choosing some more or less arbitrary number of decimal places that we're happy to put up with. So there we have it for the returns on A. And now for asset B, very similar calculation. So I'll leave out a few of the simpler steps here. Okay, so that completes our table of information up the top with the expected returns on the two assets. Now, the next question is wanting to know the correlation. Just to refer back to that question, we want the correlation between the two returns and we want to interpret that value. Now, the correlation between two random variables is equal to their covariance divided by the respective standard deviations. Now, we've calculated the two standard deviations in part A, so the immediate issue here is to calculate the variance, the covariance. Now, there's two basic approaches to this. One is to note that the composition of IA and IB, that they are C plus X and C plus Y respectively, and also that C, X and Y are independent. And that tells us immediately that the covariance is simply going to be the variance of C, because C is the element, DC is the variable that is shared between IA and IB, and the remaining part of it, the variables X and Y, are independent of C and independent of each other. So we could simply write down that the answer here is the variance of C. On the other hand, you could go and unpack this properly. Okay, so you could say, well, this is going to be evaluated as the expectation of the product of the two variables minus the product of the respective expectations. And then you unpack each of those, IA being C plus X and IB being C plus Y, and so on, and you expand it, and then you collect appropriate terms, and you will find that you get an expression that amounts to this. You get the variance of C. You also have the covariance of C and X. You'll have the covariance of C and Y, and you'll have the covariance of X and Y. And we know C, X and Y are mutually independent, and so these terms are all zero, and you do in fact end up with the variance of C. And so this leaves us with the result that the correlation between the two returns is equal to the variance of C divided by the respective standard deviations of the two asset returns. All right, so we need to refer to our summary table up here. So the variance of C is 0.08 squared. And the two standard deviations, which we've calculated, will have 0.1063 asset A and 0.08225 or 246 for asset B. And so numerically, this comes out to about 0.73. And we know that's a fairly hefty correlation, but it certainly isn't perfect. Okay, so we would say these two assets are fairly strongly correlated. And that makes a bit of sense in that the great proportion of the return, especially in asset B, is in fact what comes from asset C. All right, because the expected return on Y is only 1% compared to 5% for C, and also the standard deviation in Y is much smaller than the standard deviation in C. So X and Y, and X is in a similar situation, although less so. Okay, so C is definitely the dominant component in the composition of IA and IB. Okay, let's refer back. That concludes question B. We were wanting to calculate the correlation and a brief interpretation of that value. Okay, now in part C, just for this part, we're imagining that IA and IB are independent, but leaving the expected value and standard deviation as calculated. And then we want to know what would be the expected value and standard deviation of final wealth for a portfolio of $40 in asset A and $60 in asset B. Okay, so here in part C, the crucial thing to note is that if IA and IB are independent, then the covariance and correlation will be 0. And so we don't have to worry about such terms arising in relation to variance calculations. So if we use W for wealth, and we might have W0 as the initial wealth and W1 as the wealth at the end of 1 year, then we can talk about the mean value for W1 and so the mean value there, we're going to have our $100 in total that we invested, and then the mean returns. So we have $40 times the mean in asset A plus $60 times the mean in asset B, and that comes to 106.8 or 80 if we're talking cents. Now, in terms of variance for the final wealth, we're going to have 40 squared oops, I wrote the wrong thing there. 40 squared times the variance for asset A plus 60 squared times the variance for asset B. Oops, and we'll take the square root later. That comes to 42.56. And so the standard deviation there is the square root, of course. And so we get 6.52 or $6.52. Okay, so that concludes part C. Just checking there, we wanted expected value and standard deviation of the final wealth. Yeah, so that's $106.80 for the expected value, $6.52 for the standard deviation. Now I'm going to need another page here. And we'll be doing the last part, D. And what we have here is trying to talk about the actual situation, the actual expected value for the same portfolio, but now taking the correlation into account. So we're going to have the same mean as in part C. Because the fact that the covariance and hence the correlation now exist or are positive is not going to affect the calculation of the mean. But for the variance, we certainly do have a change in the calculation. So we're going to have some of the same parts. So we'll still have 40 squared times the variance for A plus 60 squared times the variance for B. And now we'll have to deal with the correlation between them. And so what we need here is twice the covariance. And we need to also take into account the multipliers here, the 40 and the 60. So it's 2 times 40 times 60 times the variance of C, which is equal to the covariance between the two returns IA and IB. All right, and so the covariance of the variance of C, just checking back, the standard deviation is 0.08, so the variance of C is 0.08 squared, and that's the expression that we need at that point. When we calculate that, that comes to 73.28. And so the standard deviation for the final wealth at the end of the year is the square root of that. Or $8.56. Okay, and we can note that this is a larger value than what we had before. We're taking the covariance into account. So that's a thing that the assumption of independence may be dangerous. So we need to try and evaluate the correlation, the covariance, if we possibly can when we're doing this in a realistic situation. Okay, that concludes solution to question 11. And so I'll close the video at that point.